Okay, second problem of our boards go up, please, for what are we doing? Spherical integration, 3 dimensions, total craziness. Actually, this one's not that bad. Um, all right, so I want you to integrate this function. I don't know why it should just say f. F is rho to the -3 over this region right here. So uh, this region is actually, I will give you a hint in a moment. But if you would like to just look at this problem the way it's posed right here and try it, then just go for it. Um, I'm going to give a little hint now. This region, one, this is rho squared here, right? So rho squared is going from -2, or sorry, from 2 to 4, which means that rho would go from √2 to 2. Um, I think of this thing as like a racquetball. Um, a racquetball has a like thick rubber outer part and then the air part in the middle, right? So this is kind of like a air gap in the middle with a thick shell around the outside that are both spherical. Um, I did not even attempt to draw it, right? So this region is a hollow ball where rho from 0 to √2 is air, while √2 to 2, I probably should have written, is the solid portion that we're integrating over, part of the region. So if that helps you set up the bounds, then go ahead and do it. Right, now I'll go down to the answer. The answer is 2 pi times ln of 2. Um, there are lots of different ways that you could write the answer at the end, but I think that's kind of like the most purely simplified. Um, so you could have something like this, but that's actually this. Anyway, let's go up and talk about how to do the whole thing. So that ball, the hollow ball, well, we're going to do all angles, right, for theta, and then we're going to do all angles for phi. So theta wraps all the way around and goes from 0 to 2 pi. Phi, remember, it goes from the North Pole down to the South Pole. So at the North Pole, the angle is 0, and then phi goes all the way down to an angle of pi, pointing the opposite direction. So that's why I do this 0 to pi right here. And then this goes √2 to 2. That comes from this right here. My f is 1 over rho cubed. So when I set up my integral, I get 0 to 2 pi, 0 to pi, √2 to 2 of this guy, d rho, d phi, d theta. This divides into that to give me a 1 over rho. Remember, this part right here is the volume element. Rho cubed, rho squared, meh, right? The first thing I did was notice there are no thetas in here. So I can separate these integrals, this 0 to 2 pi, or I could do that piece first, you could think of it as, right? So when I do that piece first, I just get my 2 pi. We did that a bunch with cylindrical integration, so I'm not going to talk about it much. From there, the next two variables, the rho and the phi, are both in here. So I got to do some work to do that integration. You can do whichever one you want first. I decided to go with the rho. So this gives me ln a rho, evaluated from √2 to 2, which is going to give me, oh, actually, look at that. I did both of them. No, sorry. Which gives me ln of 2 minus ln of √2. And then the next thing I did was I integrated this sine phi. That gave me a negative cosine phi. And it got evaluated between these two bounds right here. And then what I did, and maybe some of you got to like something like this with a 2, right? But I looked at that and, I'm a math teacher. So when I see a log, I want to smash it, right? So I saw that log and I said, I'm going to smash that log. I got the ln of 2 minus the ln of √2. Remember that minus on the outside, when I smash it into a single log, turns into a division. So these guys turn to that. And when I divide the 2 by the √2, I get a √2. You could think of rationalizing it, multiply by √2 over √2. and then you would get some cancellation and you'd get a root 2 by itself in the top. This cosine, negative cosine evaluated, oh, it's such a mess. There's all these double negatives. It's just 2, which gives me 2 ln of root 2 with a 2 pi, which is 4 pi ln of 2 to the half power. And again, what's my favorite? You guys know this. My favorite rule. My favorite rule is plugging it. So I plugged it, moved that half out front, and I got 2 pi ln of 2. And that is my final answer. I did that quickly. We're only at 5 minutes and 39 seconds. Um, anyway, I got one more for you that kind of is a little bit um, it's harder, right? But I hope that all these are helping you just see how to work in spherical coordinates.